This video is brought to you by Lambert W. If you want to improve your problem-solving skills and be in the community with people who like math around the world, be sure you guys go check them out. Alright, I'm going to show you guys how to solve this equation right here. X to the x power that's equal to 2. First of all, if you graph x to the x power, the curve looks like this. And if you graph 2, you get a horizontal line like that. They do intersect each other one time, so we do know we have one real solution to this equation. Well, unfortunately, if you use natural log, it's not enough to help us out to solve this equation because you see x is in the base and also in the power. So we need to have more things, and I will show you guys the Lambert W function that's actually going to help us out for this equation. And I will write down all the things that we need right here. First of all, it's a notation. We are just going to write it as w of x. And sometimes if you're working with complex numbers, you can put down w of z. But anyway, this is defined to be the inverse of a specific function, and that function is x times e to the x. And as we all know, the inverse of e to the x, that's just a natural log. But that's not enough when you are trying to solve an equation like this. So, if you have a function like x times e to the x, we are going to define the inverse of this to be the Lambert W function. And I'm going to write down two important properties for the w of x. The first thing is that you have to remember w and f, they are the inverse of each other. So if you enter f of x into w, they pretty much cancel out and you just get the x back. And in this video, I'm not going to talk about the domain because that would be too long. That will be for my future videos. So for all the x values here, they will be nice, all right? Anyway, let me actually write this down right here. So when you have w of f of x is x times e to the x, the beauty when you are looking at this is when you have this and that being the same and e for the base, and if you apply w for that, you are going to just get this right here. Why? Because once again, w and f, they pretty much cancel, you just get the x back. But this expression, you should keep in mind. We'll be using that a lot. And the second property is, well, I can enter w into f. So I can put down f first like this, and then we'll enter w of x like that. Once again, because they are the inverse of each other, so you know this is going to just give you x. And this time, I will just put in w of x, this thing, into this x and that x, because I'm trying to enter w of x into f. So this is going to be w of x right here first, times e to the w of x again, like that. And of course, if you have this expression, this is still going to give you x. And we actually like to divide the w of x on both sides, so you actually get this nice property, e to the w of x being x over w of x, like that. Once again, keep this in mind. Now, let's talk about how we can use all this to solve x to x is equal to 2. Well, I will first get rid of this x from the exponent. Then to do that, I will just take both sides and raise that to the 1 over x power. So on the left-hand side, we just get x right here. And on the right-hand side, we have the number 2 raised to the 1 over x power. Here, the base is 2, but we don't want base 2. We want to work with base e. So I will look at this 2 right here as e to the ln2, like that. E and ln cancel, so you know this is just the same as 2. And now let me write down the rest. This is x equal, parentheses, 1 over x right here. And you see this is the power. We can just multiply with that power. So we have x equals e, and then ln2 times 1 over x is just ln2 over x, like that. So now, this is the power that we have for the e. And that's pretty much this. I want to have the same thing in the front. Well, first of all, let me just write this down better. I want to have the same thing in the front, right? So what can we do? Well, it's okay. I can just multiply both sides by ln2 over x. And that's going to be so nice. Why? because yes, I will multiply by ln2 over x here, and I will also multiply by ln2 over x here. So nice. This x and that x cancel each other out. So in fact, you just have all the x on the right hand side now. So wonderful. Well, here we have ln2 on the left hand side, and that's equal to, this is just ln2 over x times e raised to the ln2 over x power. And this is exactly the formula we want. Once again, you see the front and the exponent, they are the same. Then I can actually apply the w function on both sides. And you see the left hand side is just a nice number. So let's go ahead and do that. Let's take the w of this and also take w of that. On the left hand side, this is just w of ln2, and this is a nice number. You can just use a computer to calculate that. On the right hand side, so you see this and that are the same, and you're applying w to that. Look at this right here. This and that are the same, and you're applying w to this, so you just get the x back right here, right? So in this situation, the right hand side is just ln2 over x. That's very nice. Aha! As you can see, we only have the x right here. So of course we can solve for x nicely. So I'll just take the reciprocal on both sides. And I'm going to write this down first. We will have x on the top over ln2, and that's equal to, this will be in the denominator now, so it's 1 over w of ln2, like this. And of course, we can now just multiply by ln2 on both sides. So we see x is just equal to ln2 on the top over w of ln2. And that's it. That's totally okay for the answer of that equation in the exact form. That's pretty much it. Well, notice here we have ln2, and this is also ln2 instead of the w function. In fact, if you guys look back to here, when we had x over w of x, we can write this as e to the w of x. So another form to write this is that you can write it as e raised to the w of that, which is the ln2 right here. Of course, either form is okay for the answer. Up to you to see which one that you like better. At the moment, this is pretty much it. But of course, the final question should be, how big is this though? Just like how big is ln2? We can use a calculator for it, but unfortunately, the w function is too advanced. It's okay, because nowadays we have something called the computers. Anyway, number 3 right here. If today you end up with w or whatever, this is what you can do on Wolfram Alpha or Mathematica. You can enter this as product log of x, like that. So, for example, when you have e to the w of ln2, you can enter this as Anyway, hopefully you guys all like this video, and before we go, I just want to tell you guys about blackpenredpen. If you're interested to learn about how to solve interesting challenging math questions, or just to learn about new mathematics, be sure you guys go check out blackpenredpen because they have a lot of interesting courses such as calculus, discrete math, probabilities, differential equations, and a lot more. You guys should definitely go check that out. Also, you guys can sign up for a free account and start to do the problems of the week questions. They have new questions each every week, ranging from basic to advanced. But some of the questions are really hard. You guys will enjoy it. Anyway, if you are interested to sign up for the annual premium subscription, be sure you guys use the link blackpenredpen so that you guys can get 20% off discount, which is really cool. Anyway, thank you guys so much for watching this video, and thank you so much for checking blackpenredpen, and thank you so much for supporting my videos. Thank you.